how to multiply values near 100 and numbers which are less than 100. So let's take an example. 96 into 93. Step number 1. Our base is 100. Step number 2. We'll take the difference from 100. The difference of 96 is minus 4 and difference of 93 is minus 7. Step number 3. In step number 3, we will gonna multiply the differences, which is 28, and we will write it here. So these are the last 2 digits of our answer. Now move to step number 4, where we have to do the cross addition. As we have 96 and minus 7, so we will get 89. Put 89 here, and that's your answer. Answer for 96 into 93 is 8928. Let's move on to another example where I'm going to show you what if our multiplication ends into single digit. So moving on to next example, we have 98 into 96. Step number 1, base is 100. Step number 2, differences of the numbers with base 100. So here we get minus 2. For 96 we get minus 4. Step number 3 is multiplication of the differences, which is 8. But as per the rule, the multiplication of the differences should always give us 2 digits of the answer. So we will add 0 here. For the answer, we'll add 0 here. Step number 4, we'll do the cross addition, which is 94. So the answer is 9408. So let's move to example number 3, where we are multiplying 87 into 91. Step number 1, base 100. Step number 2, difference of the number with base 100. So it's minus 13 and it's minus 9. So step number 3 is we have to multiply the differences. So the answer is 117. As per the rule we have discussed earlier as well, that the answer should be always 2 digit. It should give only the 2 digit of the answer, which is 17. So we're gonna put 17 here, and this one we're gonna carry. So step number 4 is the cross addition. As we have a negative value, that's why we are subtracting it. So the cross addition gives us 78 plus we have one carry forward, which is 79. So our answer is 7917 for multiplication of 87 into 91. How to find square of a number if you know square of the adjacent number. For example, if you know square of 40, I can tell you how to find 41 square and 39 square. Or if you know the square of 75, I'll tell you how to find square of 74 and 76 in just 2 seconds. So let's have a look. For example, if we have 40 square, so we can find 41 square and 39 square in just 2 seconds. So before going forward, I will tell you answer of 41 square. 41 square is 1681 and 39 square is 1521. You want to know how did I calculate? It's very simple. You know 40 square, which is 1600. And we'll write it here as well. So let's take a look here. So we know 40 square is equals to 1600 and we have to find 41 square. As we know 41 is greater than 40, so we have to do is add. Now what we'll add is the adjacent number and the number itself, which is 40 and 41. So the answer is 1681. Same way, we know 39 is less than 40. So what we're going to do is from 1600, we're going to subtract the adjacent number and the number itself, which is minus 40 and minus 39. So the answer is 1521. So let's move to another example where we already know 75 square and we have to calculate 74 square and 76 square. So we'll calculate 76 square and 74 square. So the answer for 76 square is 5776 and answer for 74 square is 5476. Now I'll tell you how did I calculate. We know 75 square as I already explained it to you. Whenever we get a number whose ending with 5, the square is 25 and the number multiplied by the next integer, which is 8. So 56. So 5625 is 75 square. Now since 76 square is greater than 75, so we have to add 75, which is the adjacent number, and 76, the number itself. And the answer is 5776. Now 74 square, we know the answer for 75 square is 5625. As this number is less than 75 square, so we'll subtract the adjacent number and the number itself, which is 75 minus 74, and the answer is 5476. So this is a quick trick for you guys where you know already the adjacent square and you have to find out the square for the next number or the previous number. How to do multiplication of partially complementary numbers. But before that, I'll tell you what partially complementary numbers are. So let's take up an example. 63 and 67. So in partially complementary numbers, the unit digit, when you add the unit digits like 3 and 7, it should give you sum of 10. Okay, and the rest of the number, the remaining number should be equal. So these are the partially complementary numbers. So now when it comes to multiplication, I'll tell you how to multiply these partially complementary numbers now. So let's take step number 1. In step number 1, what you have to do, you have to multiply the unit digits, which is 3 and 7. So when you multiply 3 into 7, you'll get 21, right? So these are the last two digits of your answer. So to get the rest of the answer, what you have to do is you have to take this number, which is 6, and take the next integer to 6, which is 7, and multiply them. And you'll get 42. So put this 42 here, and your answer is 4221. You can cross-check with your calculators. So this is the first example, and now we'll move to the next example. Example number 2, in which we are multiplying 42 into 48. So step number 1, multiply the last two digits, which is 8 into 2, gives 16, and then the remaining number, which is 4, into the next integer, which is 5. So 4 5s are 20. So your answer is 2016. So that's how we do multiplication of partially complementary numbers. But what if your answer of the last two digits results in a single digit? In that case, we have to always add a 0 before the single digit. So now let's move to example number 3, which is 81 into 89. So again, our step number 1, multiply the unit digits. So now when we are multiplying the unit digits, which is 9 into 1, our answer is 9, which is a single digit answer. So in that case, we should always add a 0 when we are putting it here, because we should have the last two digits of our answer by multiplying these digits. Okay, so the next step, which is step number 2, in which we are multiplying 8 followed by the next integer, which is 9, and the answer is 72. We'll put it here. So here's our answer, 7209. So now let's take example number 4, where we are multiplying 124 into 126. So when we multiply this, again our step number 1 is we have to multiply the last digits, which is 4 into 6. It gives you 24. and then the remaining number, which is 12, into the next integer, which is 13. So 12 13s are 156. And that's our answer, which is 15624. So this is how we do multiplication of partially complementary numbers. I'm going to teach you how to multiply values near 100. These type of tricks are very important when you go for competitive exams and you get questions like percentage, interest, all such questions. When multiplying values near 100, there are three cases: values which are greater than 100, values which are less than 100, and value which is 1 plus 100 and 1 minus 100. So all these cases we'll discuss later, but in this class we will discuss about values greater than 100. So let's take an example. The example is 107 into 104. So our step 1 is, step number 1, we always take our base as 100. Okay. Step number 2, we take the differences of these numbers from 100. Like if it is 107, so the difference is 7. 104, the difference is 4. Move to step number 3. In step number 3, you have to multiply the differences, which is 7 into 4 is equals to 28, and write it down here. So this is the last two digits of your answer. Moving on to step number 4. Step number 4, you have to do the cross addition. You can either add 107 plus 4 or do 104 plus 7, and you will get 111. And put it here, 111. And our answer is 11128. So this is one example where our digits are already 2 digits. But you can get some questions where digits are even 1 digit or 3 digit. We'll move on to next example and see how we can solve them. So step number 1, our base is 100. Step number 2, we'll take the differences. Here it's 2, here it's 3. Step number 3, multiply the differences. When we'll multiply the differences, we will get 6. As 6 is a 1-digit number, and as per the rule, we should always put 0 before 6 while writing here for the answer. And step number 4 is cross addition, where we will gonna add 102 plus 3, which is 105. So our answer for 102 into 103 is 10506. I want to stress a point here. Multiplication of the differences always gives us the last 2 digits of the answer. So in case we are getting only 1 digit, we should put a 0 before that. So let's move to the next example where we are multiplying 108 into 114. Step number 1, base is 100. Step number 2, the differences. 108 is 8 and from 114 it's 14. Step number 3, multiply the differences. So when we are multiplying the differences, our answer is 112. Again, I want to stress here, the multiplication of differences always gives us the last 2 digits. So these 2 digits we put here, and this 1 we're gonna carry. Step number 4, we're doing the cross addition. So this gives us 1, 2, 2, but we have to carry this one. So we have to write here 1, 2, 3. And that's your answer for 108 into 114. Our answer is 12312. How to find cube root of perfect cubes? So I have a table here for you in which we have number 1 to 10 and their perfect cubes like 1, 8, 27 respectively to the numbers. Now, there's one very interesting thing to observe. If the perfect cube is ending with 1, 4, 5, 6, 9 and 0, then the cube root is also ending with the same digit. See? If the perfect cube is ending with 2, 3, 7 and 8, then the cube root is ending with 8, 7, 3 and 2. Now let's take an example. So now look at this example where we have to find cube root of 250047. As I told you, if a perfect cube is ending with 7, then its cube root is ending with 3. So our last digit is 3. In step number 2, forget about last 3 digits and concentrate on the rest of the number. So our rest of the number is 250. Now to figure out for this, we have to see the highest cube which is less than 250. And when we go to this table, we'll find the highest cube less than 250 is 216, and the cube root for this is nothing but 6. So we have to mention 6 here, and that's our answer. So cube root for 250047 is 63. Isn't it simple? So let's move to the next example in which we have to find cube root for 175616. As I told you earlier, if the perfect cube is ending with 6, then the last digit of the cube root is also ends with 6. So last digit of answer is 6. Now we can forget about 616 and concentrate on 175. Now we have to find the highest perfect cube which is lesser than 175. So we'll go here, which is 125, and the cube root for 125 is 5. So we'll write here 5. So our answer is 56. So cube root for 175616 is 56. I'm going to tell you how to find square and square roots of some interesting numbers. Let's have some examples. So this is an example. Isn't it such a long or a big number? But the answer is very simple. Okay, so the answer for this is do you want to know how? Okay, so the answer for this number is very simple. You have to count how many ones do we have. 1, 2, 3, 4, 5, 6. So we have 6 ones. So we'll start from 1 and we'll go to the ascending order 1, 2, 3, 4, 5 till 6, the number of ones we have, and then we start descending till 1. So 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Isn't it simple? Okay, now let's take another example. Let's say 1, 1, 1, 1 square. So we have 4 ones. So we'll start from 1, 2, 3 and we'll go till 4 and then we'll start descending. So the answer is 1, 2, 3, 4, 3, 2, 1. So now let's take this example. So it's again very simple, like 1, 2, 3, 4, 5, 4, 3, 2, 1. So the square root for this number will be 1, 1, 1, 1, 1. Do you want to know how? So let's see, this is the same number, the same example which I showed you here. So it is starting with 1, it is going till 5 and after that it is descending. So we have to write 5 ones here. The biggest digit we have when we are ascending is 5, so we'll write 5 ones here. So now let's take another example. So the another example we have is we have to find square root of 1, 2, 3, 2, 1. It's again the same example. We are starting with 1, we are going till 3 and then we are start descending. So we have to write 1 3 times. So the answer is 1, 1, 1. With this you can have another example like we're going 1, 2, 3, 4, 3, 2, 1. You know the answer. The answer is 1, 1, 1, 1. So guys, don't you think these are very simple tricks? Sometimes your observations make a huge difference. These numbers may appear very big and very difficult, but their answers are really very simple. I hope you all enjoyed this. So keep watching us as we are coming with more and more good techniques for you guys, and please subscribe.